Hi guys, welcome back to the session 19 of Java Full Stack Made Easy. In the previous session, we spoke about the interfaces. We spoke about how interfaces can be a parent of another interface, how a class can implement more than interface. So the set of rules and everything we have discussed about the interfaces. If you have not seen that particular video, go back to my channel and watch that video because this is a continuation of the same video. So here in what I'll be doing is I'll be creating another simple example of interfaces, like where do you use interfaces in real time, and then after that we will talk about the marker interface. So in the last session I told you we will talk about the marker interface in our next session, which is an interface without any method body. So in the previous example we have taken the example of the bird, aircraft and the Superman. All of them fly, right? Share the common behavior, but they were not related at all. Similarly, what I will do is I'll now take an example of maybe the devices like a TV and an AC or a fan. So these devices, what I am thinking of is all these devices will be controlled by a remote control. And the features that I want to implement in a remote control would be turning it on and turning it off. It can be a TV, it can be a fan, or it can be any device, okay, so which I want to turn on and off on a remote control. I want to control it remotely. So that is something which I am thinking of. So let's go ahead and first design it. That means let's graphically understand that what I want to have is I'll have a class TV, then an AC, a fan. So it can be anything, right? So I'm thinking of these three classes which will be controlled by a remote control. So all of them, they share the common behavior, that is turning them on and off through a remote control. Okay, so this is what I want, and a remote control will have this feature like turn on, turn off. So this feature will be available in a remote control, and how they do it differ. Each of them do it differently. Okay, so each one of them has to define turn on and turn off, and like in the last example itself we have seen, although the methods has to be defined by this TV, AC and fan itself, but they enter into a contract with the remote control. So if any of this class says that it is controlled by a remote control, it has to have the method turn on and turn off. So that's the main agenda behind creating the interfaces, because interface is set of rules, right? It's kind of a contract between the class and an interface. What is the contract? The contract is that the class has to define these two behaviors for sure. So that's what I'm thinking of, and each of this device will turn it off and on in a different way. Okay, so let's design it that way. So here I go. I will first create a remote control as an interface. Interface remote control. So this interface will have two functionalities in it. That is going to be void turn on. All interface methods are abstract by default. That's something which we have discussed in the previous session itself. Void turn off. So I'm done with my interface. Let's now design the three classes that we have discussed. So class 1, which is going to be a television TV. This will implement the remote control. Obviously, when it implements the remote control, it has to override the two methods that I have written there, turn off and turn on. These methods has to be overridden. So when I'm overriding this, I'll not implement any complicated code here. I'll just say TV is on and TV is off. Okay, system.out.println. So when somebody turns it off, it says TV turned off. Okay, and here I'll just say TV turned on. Similarly, I'll have other classes like AC and the fan. That's what we have discussed, right? So let's have two more classes. Which again implements the same, and it has to override the same methods. So I'll just copy this and say implements again the remote control. So this class again, AC class, is entering into a contract with the remote control. The contract is that it has to override the methods. So AC turned off, AC turned on. Similarly, let's create one more class. So these all classes can be non-related. They are not non-related itself. They are neither the siblings, nothing at all, right? But they share the common behavior. A fan class again implements remote control. So when it implements that, I have to override these two methods. Okay, so I hope that this would be a more realistic approach to using the concept of interfaces, and by implementing this, we should be able to relate this to a real-time example. So let's now create the service, which is the main class. Let's call it as a remote service with the main method. So now I want to create this instance in such a way that the remote control should control any device. Okay, so this interface remote control I have created. Remote control rules are what any device that wants to be controlled by, that means any device wants to be controlled remotely, must have the method turn on and turn off. And what we have done is we have implemented that remote control with TV, AC and fan. All those three classes, they agree to that contract, the rules that we have created, and they provide their own version of turn on and turn off. Okay, and we can here use the concept of dynamic method dispatching, the polymorphism, by creating the instance of the remote control and referring it with different classes, so that the same instance can be used to turn on and turn off the devices based on the object that is passed. So let's create that. I'll say remote control, and this device as for now equals to new. I'll create it for AC. Okay, and then if I do a device dot turn on, it will turn on the AC, and device dot turn off, it will turn off the AC. System.out.println, just a simple line between this so that we can see the results differently. And then I can say device equals to new fan, and then again device turn on turn off, it will turn and off the fan. Similarly, I can do the same with the last class, that is AC, right? Yeah, AC I have already created. The TV, device turn on turn off, so TV will be turned on and turned off. So that way, now this example, what you can think of is, think of a universal remote control which can actually turn on or turn off the AC or TV or fan. So you don't care whether it is controlling TV or fan or an AC. You just turn it on and off. That means you press the button on and press the button off. So how it manages the device, it's on its own way, right? We don't care whatever device we have initialized. So based on that only it will turn on and turn off. So it's kind of a universal remote control that I have created. So I run this and you can see that I can turn on or off the AC or a fan or a TV. So this is how we can basically create interfaces, and that's how they bring in the concept of a contract between the class and an interface, which has to be followed like a set of rules, the protocol. Fine. So we have discussed about the rules and the inheritance concept into an interface and everything in our previous example itself. So this was just a more realistic example I wanted to share with you. Now what I will do is I'll go with the marker interface and we will see the use of a marker interface. So this is our session 19. So let's create a repository for the same. Let's call it as day 19 / demo 1 more realistic example of interface. So here I have a remote control that controls all my devices. Now, how does it differ from an abstract class is that in this case, if I would have implemented an abstract class for a remote control instead of creating it as an interface at that time, this TV, fan and the AC would become the child of a remote control, where remote control is not a parent of the TV and all that, right? So that's why we are not implementing an abstract class in this case. I hope you got that point. If I mark this remote control as a class at that time, this TV, AC and fan has to extend it. If they extend it, then TV becomes a child of a remote control, which is not true, right? Now, coming to the other example, I have already added this example, so I'll close everything that I have created here once again. And now we will talk about the marker interface. Now, what is a marker interface? A marker interface is one that does not have any method at all. So I can just go ahead and create an interface, and let's just call it as demo marker, and I can just finish it and then say that this is a marker interface. So marker interface is created, an interface without any body. Now, very strange question comes up into our mind is that why do we use marker interfaces, right? If an interface does not have a method at all, then what contract it is creating with the class? And what is the use of an interface that doesn't have any body at all, right? But I will tell you that in Java, there are built-in marker interfaces. There are some interfaces which are already created, pre-created. So although this is a class, if I make it an interface, you can see that it is a marker interface, an interface without any method at all. So Java does have such type of interfaces, which is just a marker. It doesn't have any method at all. One such interface is serializable in Java. So if I give you an example, class ABC, I create this class ABC, and if I implements a serializable, so you can notice that when I create this ABC, it is not giving me any error saying that you have to add the unimplemented method. You see that? No, serializable does not give me any method. That's because it's a marker interface. Marker interface is one that does not have any method at all. So you can even browse for the available marker interfaces in Java. So Java does have marker interfaces created for us. So why do they create a marker interface, and in what scenario a marker interfaces can be used? So let us think of again a real-time example, and let's appreciate the concept of the marker interface. Okay, so I'll just close this and we'll try to put all of that into a realistic example. So let's create it into a pack one. So what I have is I will create a marker interface here. Okay, so now let me just first summarize the example which I am thinking of, so that it will be easy for you to understand what exactly I am implementing. So what I am thinking of is, let's go here again to our drawing board. I want to have a document. This particular user, there is a user who's the owner of this document. So there is one person who's the owner of this document. Okay, this user owns this document, and this document has some data in it. So there is one class which is printer. What will this printer do is print the document. So whether the document should be printed or not is decided by this user, the owner, right? The owner should decide whether the document can be printed or cannot be printed. Whether you want your document to be printed or not printed is decided by this particular user. Let's call this user as X. Okay, so this user X decides, because he owns the document, he should decide whether the document can be printed or cannot be printed. Okay, so this is what I'm thinking of. There is a document. If this user allows printing, then it has to be printed. If this user does not allow printing, then it should not be printed. So that's what I'm thinking of. Fine. So let's first go ahead and create a document. So I'm creating a class. I'll call it as document only, or else I'll call it as my document. So let's finish this. And this document just does what? Void my document system.out.println, or let's just say string my document or something. My document, instead of my document, let's call it as my data. So this document has to be printed. I'm just saying string, and I'll return the message instead of writing a system.out.println, so that it just does not print it on a console. It can be used by the user however he wants it. So this is my data. So this document is there, and now I will create a class that prints the document. So I'll call it as my printer. Okay, so this my printer will have a function called as void print document. Okay, which takes the document instance, which is my document here, doc, and what it does is it just says system.out.println document dot, what method I created, my data. Okay, it does only printing, that's it. So I will see whether the document now can be printed or not. So I'll save it, and I'll create a main class for this class, printer service, with a main method. Let's now try and print the document. So I have to create an instance of my document. Document is equal to new my document, and document dot, now printer should be there, which is my printer. Printer is equal to new my printer, and I'm saying printer dot print document my document. Okay, when I save it, I'm able to print it, right? This is my data. So I'm trying to print the document, and it is able to print the document. So this is the example. So there is a document, and that document will be printed by the printer. So I have created that document. Printer is printing that particular document, and here is the service where I'm printing it. So now, as I told you here, the owner should allow the printing or not. See, this should be a responsibility of this owner, whether he wants the document to be printed or not, whether he allows printing or not should be the decision of the owner of this document, right? So in this case, what is happening is, all the time you call this print document function, it is printing it all the time. This is my data, so it is printing it. How can this my document restrict printing here, right? Whether he wants to allow the printing or not should be dependent on this my document. So how can I organize this code in a way where if this user allows printing, then the printing has to happen. If the user does not allow printing, then the printing should not happen. Okay, so let's go ahead and understand that, and let's create it that way. So what I'm going to do here is, I will create a interface here, and I'll call this as allow printing. Okay, so I'll just finish this. Allow printing has no method at all. It's a marker interface. So in my printer, what I will check is, I will only check if document instance of, if you remember, instance of returns you true if the instance that we are creating belongs to the same class, right? Document instance of allow printing or not. That means if the document allows printing, do this. else system.out.println, this document cannot be printed. So that's what I implement. I'll save it, and now you see that when I'm trying to print this document, I run this piece of code, you see that this document cannot be printed. That's because the owner of that document, my document, it is not allowing the document to be printed. So if I say implements allow printing, the moment I say implements allow printing, now the same document, if you are trying to print, if I go to printer service, and if the same documents, if I try to print now, you can see that this is my data. So it is printing it. And if I don't allow that printing, if I don't enter into this contract, then the printing does not happen. You can see that. So in this example, what am I doing is I'm actually using an interface, right? An interface without any body at all. So that interface itself is telling whether the document can be printed or cannot be printed. So it's like a marker. You give a check mark, right? Allow printing or not. So by implementing this allow printing, I'm saying that this document can be printed. So when I implement this, then my printer is capable of printing this document and it is printing me the data. If I don't implement that, then my printer will not print it because it will not be an instance of allow printing. It checks whether the document can be printed or not. Now it finds that the document cannot be printed, so it says this document cannot be printed. So I hope with this simple example, simple yet more realistic example, you understand and appreciate the use of marker interfaces. So what you can do is you can just check, you can add, implement allow printing, or you don't implement it and check whether the document can be printed or not. Okay, so you can create another class and then I'll do that for you. So what I'll do is I'll just create one more document here, create a class my document 2. Okay, so my document 2 will be like my document itself, everything will be the same, that data and everything. So I'll copy it and put it here, and both will I'll create one more class here. See, in a more realistic way this can happen. So I'll create a class, I'll call it as document. Okay, and this will be an abstract class which will have the method string my data. That's the method I've taken in both the documents, right? My document 2 and this document. Yes. So since it is an abstract class, I have to mark it as abstract string my data. So that's fine. My document will extend the document, extends document. My document 2 will also extend the document. Okay, let's save it, and in my printer we will try and take the document instead of my document directly. So I have the document and check it. Now if I go to the printing service, same my printer, it is the document first, document doc is equal to my document. Next time doc will be is equal to new my document 2. Okay, and the printer instance is already there. So printer is trying to print the document, and here also it is trying to print the document. Here it is document 2. Okay, so let's create an instance and call it as document 2 so that there is no confusion for you. So I have two documents, document 1 and document 2. This is document 1 and document 2, document 1 and 2. So you can see that document 1 is my document. My document allows printing for me, whereas my document 2 does not allow printing for me, right? So I'll go to the printer service, and when I run this in document 2, what I will do is, this is my data, or let's call this my document as this is my data or printable data, and document 2, this is my data, cannot be printed. Okay, let's save it, and let's go to this printer service now, and you will see that when I run this, first document will be printed. This is my printable data which is printed, and the next one is this document cannot be printed. Same method behaving differently for two different documents. So document 2 does not allow printing, that's why it cannot be printed, whereas document 1 allows printing, that's why it is being printed. So this way you can make use of the marker interfaces. I hope this example makes sense and it tells you where marker interfaces comes into picture. Okay, so let me add this. If there is any doubt, you can always ask in the comment section. So demo 2, marker interface. Okay, so this is my marker interface and there are two documents which either allows printing or not. So I'll create a document. So in this example, I have created the abstract classes and also I have created interfaces. This is how exactly the real world Java looks like. So my document which allows printing, the data will be printed, and my document 2 which does not allow printing, that's why the data will not be printed. Okay, let's call it as instead of cannot be printed, we'll say this is my data or this is my secure data. Okay, after that I have already given you allow printing. Let's go to my printer. My printer checks whether the document can be printed or not by using instance of, and if it allows printing, print it. If it does not allow printing, does not print. Okay, so let me just verify if I have given you all the classes or not. So first of all, the allow printing marker interface, yes, it's given. Then the extract class document, that is also given. Then my document 1, my document 2, then the printer, my printer, and the printer service. So I have given you all the documents. Let me just commit this one. So if there is any doubt on this, you can always ask the question. So as for now, up to the interfaces we have discussed, but there were slight changes into the implementation of interfaces in Java 8, which definitely we will discuss once we discuss the concept of Java 8 features. Okay. So in the next session, we will talk more about the more realistic approach of Java development, right? So I hope whenever we discuss about the Java 8 features, at that time we will talk about the new things that are introduced into interfaces. Okay, and in the next session we will also talk about something called as the anonymous classes and all. So or else what we can do is we can discuss that concept of anonymous classes when we come to Java 8 features itself. So in the next session we will talk about exception handling. How do we make use of the exception handling? How do we create custom exceptions? How do we make use of all the keywords about the exceptions in our next session? So I hope you're liking in the series, and if you're liking it, do subscribe to my channel and like, comment for a better reach, which actually encourages me to create more such content for you. Thank you. See you in the next video.